I would like to discuss a general overview of HVDC transmission system. What is the HVDC? High voltage direct current transmission. So in this transmission lines, so only active power will be associated with the HVDC. Only real power, high voltage alternating current transmission, both actual and reactive power flows with the AC alternating current P and Q. So in this case, HV is only a single line, and whereas the HVAC, three phases R, Y, B will be transmitted from the sending end voltage to receiving end voltage, from sending point to the receiving point. So this is a basic image of the HV and AC transmission lines in HVDC system. Only so the distance length from sending end to the receiving end voltage, the losses will be very less, decreasing. Whereas the AC systems, so AC transmission lines, sending end voltage and receiving end voltage, the distance will be increasing from the sending end voltage, the losses will be increasing. What is the HVDC? The AC is converted to DC, and again this DC will be transmitted to the receiving ends, and again DC is converted into AC. The basic power flow equation is that Vs into Vs minus VR by R, only governed by the Ohm's law. It means direct current. ID is equal to V minus VR by R, where R is the resistance of the conductor, where Vs is the sending end voltage, VR is the receiving end voltage. What is the HVAC? The sending end voltage will be the voltage sending from sending end O side to the receiving end side. In between the conductor having the reactance, the reactance will be influenced by the atmospheric conditions. The basic power flow equation for is equal to Vs into VR by X into sin theta, where theta is the phase angle difference between the sending end voltage and the receiving end voltage. It is governed by the reactance VR from inductance and capacitance. What are the advantages of the HVDC systems? A long overhead line that is above 500 kilometers, near to the 1000 kilometers. The bulk power will be transmitted to near to the 1 to 2 gigawatt. No limitation or stability, free from stability and capacitor limitations. HVDC transmission line has less right of way requirement and less expense in construction. HVDC only two phases. One is the phase and the second one is the neutral. And HVAC three phases is required because R, Y, B. So low transmission loss because no reactive loss, lower installation or clear of the conductor. DC voltage is only about 70% of the AC peak voltage. AC is defined by the RMS. Power transmission between asynchronous systems, also fast power flow control, enhancement of AC system stability, supplying more active power where AC system is at the limit of its shortcut capability. The HVDC advantages: HVDC is generally less reliable and has low availability than the HVAC, mainly due to the extra conversion equipment and maintenance is the difficult. These are the disadvantages. Tapping for multiple grids is difficult. HVDC circuit breakers are difficult. Pollution detection of the outer insulator is faster. AC filters are required to absorb the harmonic component. Clean boom of the aerosol wall is necessary. This is the comparison between the HVDC and the HVAC. So this is the distance, the capacity. This is the distance, long haul capacity. So HVDC is a 1 to 2 gigawatt, but it is limited. So transmission stability, no limit, but it is limited in HVAC system. Right of way bulk transmission lines, overhead lines, low, high. So long transmission loss low, high. Insulation and clearance is low, high. System connection is always asynchronous, but it is always required synchronous system. Power flow control easy and fast, but it is very difficult in HVAC system. Multiple terminal, difficult and costly. Simple and easy. And a short circuit limitation, effective and not effective. Relation effect, more pronounced. High insulator, 3 phase is required. Relatively less. Why HVDC rather than the HVAC? Cheaper in long bulk power transmission. Asynchronous link. Accurate control of power flow both in magnitude and direction. Fault isolation. Improve the link stability. So this is the comparison of right way for 2 gigawatts. For 2 gigawatt bulk power transmission lines. So this is the 405 kilo AC lines and 405 the kV DC lines. This is the difference between the two. And the next one, this is the cost comparison of HVDC and HVAC overhead lines transmission. Types of HVDC transmission system. Monopolar system, one pole, one set of conductor for transmission and current return power through the earth. Mainly used for the submarine cable transmission lines. This is the N-type design. This is the one cable is required only for one phase of the conductor is required for the earth is the return path. This is the one type of the HVDC system. The second one is the bipolar system. Two poles, two sets of the conductors in transmission lines. This is the one conductor, this is the other conductor. So one is the positive with respect to the earth and other is the negative. The midpoint of the bipoles in each terminal is earth an electrode line and earth electrode. In normal condition, power flows to lines and the negligible current to the earth electrode. So these are the bipoles, two conductors. One is the earth negative and one is the positive. So these are the two bipolar systems. This is the one bipolar system, this is the second bipolar system. So back-to-back connection. Suppose any usually bipolar system without earth return, then will be connected whenever converter and inverter are located at the same place. Both will. This is the converter, this is the inverter. Both are in the same place. No HVDC transmission lines provides a synchronous tie between the two different AC networks. The power transfer can be either direction. In this case, so the receiving end voltage and sending end voltage, both there will be the different frequencies. Then we can synchronous will be synchronized. It means converted into AC to AC. Again, this DC is converted to AC to the required sending receiving end voltage side. So this is the multi-terminal system. This is the one type of the. There are 3 or more terminals are connected in parallel. Some feed power and the reactive power of the HVDC provides inner connection among the 3 or more AC networks. This is the types of the HVDC.